Year 10, it's Miss Bailey here. Please have the worksheet ready so you can be filling it in as we go through this video. So to start with, you've got 3 retrieval questions for your Do Now task, so please pause the video whilst you have a go at those. So the products of a neutralization reaction, this is what we looked at last lesson, and that is a salt and water. With our ionic equation for this reaction, we were looking at the ions which changed during this reaction, and that was our hydrogen ion from our acid plus our hydroxide ion from our alkali, and that made water. And we can include our state symbols of aqueous for our ions that were dissolved in water, and then liquid for the water that then got produced. Explain how indicators can be used to determine the point of neutralization. So indicators have a colour change depending on the acidity and alkalinity of solutions. And so we can use this colour change to determine the point of neutralization, as it can be used to identify the point at which our pH becomes 7. So for example, universal indicator would be green at a pH of 7. However, universal indicator, because it's got that range of colours all the way through the pH scale, not often the indicator that we would use to determine it. Instead, we use indicators which have distinct colours for acid, alkali and neutral. So today we're going to be doing about alkalis and bases. So just to recap from last lesson, so addition of alkali solutions to an acidic solution increases the pH and makes the acidic solution more neutral, whereas addition of an acidic solution to an alkali solution reduces the pH and makes the alkali solution more neutral. So a base can be defined as a substance which neutralises an acid, and therefore we are talking about something which is very similar to an alkali. Before we get on to that, could you please pause the video and write down the definition of a base? So alkalis are actually a type of base. So alkalis are soluble bases, and this means that they can dissolve in water, whereas other bases cannot. So all alkalis are bases, but not all bases are alkalis, because some bases are insoluble and so are not classed as alkalis. But both our alkalis and our bases have a pH greater than 7, and therefore will be used to neutralise acids. So examples of some bases, we have our copper oxide example up here, and you can see that it hasn't been able to dissolve in the water. Whereas our sodium hydroxide here starts off as a white solid, but you can see clearly that it has been able to dissolve in water to form a colourless solution. So our soluble alkalis are typically metal hydroxides, whereas our insoluble bases, so our bases which are not alkalis, are typically metal oxides. So I just want to give you a moment so that you can be noting down about alkalis versus bases, so from this slide but also from this previous slide. So pause the video whilst you have a go at this. Okay, so we can use what we know to make a decision about how we can determine the difference between alkali, base, neutral and acid. So the first thing we want to do is we want to split up into alkali and base compared to neutral and acid. So we can use what's similar between our alkali and our base to make that decision, and that's the pH. So is the pH larger than 7? If the answer is yes, then it's going to be leading us down to either an alkali or an insoluble base. Whereas if it's not, then we're leading us down to the neutral or the acid example. So we then want to consider what's different between an alkali and a base, and that's its solubility in water. So our alkalis are soluble in water, but our insoluble base is not. We can then consider our pH in order to determine the difference between a neutral and an acid. So pH being equal to 7, that's something that's neutral, whereas if it's not equal to 7 and it's not larger, then it must be an acid because it must be less than 7. So what we can now look at is our neutralization reaction. So acid plus base. What do we think it's going to make in a neutralization reaction? So we can look at an example. Sulfuric acid and copper oxide is going to make this blue substance and water. So this blue substance is actually also a salt. So as well as acid and alkali making salt plus water, because bases are very similar to alkalis, they actually react in a very similar manner. So both these neutralization reactions form a salt and water. And so thinking about how we're going to name this salt is going to be the same principle as how we previously named salts. So the first part coming from the metal that's come from the base, and the second part coming from the type of acid that we used. So we're going to have our copper, and the sulfuric makes a sulfate. So copper sulfate. And finally, ammonium salts. So ammonia is a substance with the formula NH3, and this can react with water to form a weakly alkaline solution. So remember, with weakly, that means it is reversible, and therefore we only have partial ionization in water. So it's not a complete separation. But it does form an alkaline solution, which tells us that it's soluble. And it will undergo neutralization reactions in the same way that alkalis do, to make a salt, which is going to have an ammonium part to it instead of a metal. So for example, ammonium chloride. So that ammonium ion is what's come from the alkali, and then the chloride would come from the acid. So pause the video whilst you note that down. And then what I'd like you to do is have a go practicing the word and symbol equations for these acid and metal oxide, or our base, reactions. So in this first question, you need to be identifying the errors that have happened in this equation, and then for the task you need to be doing the word equations for these acid and base reactions, then identifying the chemical formula for these, making note that our oxide is an O2-, so thinking about the charges of our metals and what the ratio between those different components are going to need to be for it to overall be neutral. And then for the triple side, remembering that the Roman numerals can be used to determine what the charge is of our transition metal ions. And then finally, word and balanced equations for each of those reactions. So pause the video whilst you do that. Thank you all for watching, and see you next time.